Okay, folks, if you're watching this video, then you're either one of my students or you've just stumbled across this. Just for a bit of context, we're looking at some data from an experiment where we're looking at the relationship between the length, L, of a pendulum and its period, T. Now, in this case, L is the independent variable, it's what we're changing, and T is the dependent, and that's what we're going to be measuring. Now, I've got a set of data here. We're going to use this, but hopefully you've got your own data that you can compare this to. Just a small note, my data is probably a bit better than yours. I've been a little bit creative with it to make sure that we get some nice trends and that we can see how it works. Don't worry if your data is not the same as mine or if it gives different results. That's completely fine, especially in an IA. It gives you something to talk about. So the first task that I set my students is to plot a graph simply. Okay, and the way we're going to do that is by taking these values and calculating the average. Now, most of you will know how to calculate an average, add the numbers up and divide them up, in this case, by 3. I've just realized my labeling there is a bit confusing. It's T3 in seconds. So what we're going to do there is, well, we could just add those numbers up. We could do it on our calculator, but we want to use Excel as much as possible because these numbers will be helpful later on. So actually what I'm going to use is something called the average function. Now, the way to use this is you open a bracket and then that will allow you to select these values here. Now, frustratingly, my keyboard is annoying me today, so I'm just making sure I've got the right brackets. There we go, close the brackets, and there we've got the average. No need to worry about significant figures here. If I wanted to, I could format the cell, but I'm not going to worry about that too much. So there's my average value. Now, the reason I like using this instead of the sort of brute force numbers is that what if I get one of those numbers wrong? What if I maybe misread this one and actually it wasn't 0.51, it was actually 0.54? Okay, well, that would then be reflected back in the calculation that Excel has done. Okay, and so therefore we can actually keep track of all those changes. Excel is a live document and Google Sheets, I should say, and therefore it allows us to track those changes. So what we're going to do now is we're going to do that for the rest of the values. Now it's very easy. We just go to copy. We just go here, right click to paste. And lo and behold, we've got some fantastic data there. What we want to now do is we want to plot a graph of that. We're going to press down onto these guys. We're going to press the control button. And then we're going to highlight this column as well so that they're both selected. We're going to go to insert, which I'm helpfully already on. And then we're just going to come down here to the scatter. And lo and behold, there's our wonderful graph. Looks fairly linear. Could be, we're not sure. That's what we're going to work out. So what's missing here, obviously labels, etc. And you can add these by clicking on the plus tab here. Okay, axis titles would be required here. I'm not going to worry about that too much right now. I'm going to look here at error bars. Now, we'll do it this way. In class, we've been learning that error bars our uncertainties are going to be estimated through simply half of the range. So what we would do here is we look through our data and we go, okay, what's the biggest number? Okay, that's 0.79. What's the smallest number? 0.51. Take them away, divide by 2. And that's okay, but again, there's ways of making your life easier. What we're going to do here is we're going to use a couple of functions in Excel. We're going to firstly use the max function. And again, open the bracket, select the data, just like you've done before. And that will identify the maximum number. Now, what I can do here, not surprisingly, there is a min function as well. And again, it works in exactly the same way. I open up the brackets, I press that, and that will give me the difference between the biggest and the smallest number. Max take away min. Well, now, what I need to do is go and do this again, but divide it by 2. There you go, I've got 0.14. And again, I can copy and paste that into the next cell. So I've got copy. This time I'm using the Control C. I'm going to use Control V, plot that in, and there is a wonderful set of errors. And you see there, I didn't have to do it all myself. I check the first calculation, makes sense, okay, then I can just crack on with the rest of it. Now, why have I done that? Because on Excel, I can add my error bars. Error bars, simply click them. Now you notice there, Excel comes up with faults. Okay, first thing first, we can click on these X error bars. We'll get rid of them for now. We could go back to there. And we're going to click on the Y error bars. Now you notice there, I think they've been given a standard value, okay, and that's not appropriate here. We want to actually put the value which relates to our experiment. So we're going to go to more options down here. We're going to click on the arrow, more options. And then we're going to go to custom. as you can see just off the screen, specify values. And all you have to do here is make sure that each of these boxes has the same value. Okay, just show you what happens if I don't. I'll have one short and one same length on the bottom there. So we'll just go back, specify values again. Okay. And hopefully what we'll come up with is something nice and symmetrical. That looks lovely, actually. Okay, we've got a graph there with error bars. So you've got a bit of a bigger error bar on the bottom, on the earlier values there. That makes sense because it's harder to measure those smaller times. And then our error is kind of getting fairly consistent up there. That's really nice. This is what is expected of you in your IAs. Okay, you should be able to work and produce a graph with errors in it. You should also be able to fit a curve to it. So we'll just do that one more time. We've done this a few times in my class. It's always tempting to fit a linear trend here, and you could do that. Okay, you can display the equation. Let's move that up here. And yeah, that would sort of work for now. Okay, however, there are other things we can do. Okay, we can look at the R squared value. Now, the R squared value is a measure of how good the fit is. In this case, R squared is 0.98. What you want is R squared to be as close to 1 as possible. So what we'll do now is we'll say, okay, although 0.98 is pretty close to 1, why don't I see if I can get anything better than that? And I'm going to do that by using a power law. I'm going to fit a power law. Ooh, that looks quite good. Looks like an even better fit. Okay, and we'll display that equation on there. We've got some kind of value, 1.9753. We've got power there, 0.48. 0.48, that's approaching 1/2, which suggests maybe there's a relationship with x to the power of a half. Come on to that later. How can we tell if it's a good fit? Oh, you look at R squared again. R squared this time is 0.996, very close to 1, which suggests that this is a good fit to our data. Okay, I think that's enough for now. What we're going to do next in the following video is look at how we then linearize this graph and see if we can take any data from that to establish the value of G.